I'm Lynn McDougall and I'm a science teacher at Stocksbridge School.
Right, so remember, be good.
I came up with the idea for doing a radiations officer because we all have certain parts of topics which I suppose are a little bit dry and involve getting a lot of information across to the students, and this seemed like a very fun way of doing it.
Stop straight. As usual, every time I come here, your teacher seems to have managed to have broken. Do you know what this is? Smoke alarm. It's a smoke alarm. So, does anybody know how this might tie in with what you've been doing?
Is it alpha decay?
It is. You're very good. I'm very impressed. Right. So, I may as well talk to you about this while we're working through it.
The idea of the lesson, in this instance, I was using it very largely as a lead-in to their coursework and to get them thinking about the whole idea of alpha radiation, the nature of alpha radiation, why we would use it in a smoke alarm, why we would worry about it being a smoke alarm, why some people might not want it in their homes, and, of course, why people don't need to worry about it being in their homes.
Can anybody remember how a smoke alarm works, or would you like me to demo it again?
Demo.
Yeah. Ah, you see, this is going to need you lot then.
The next thing is try and emphasise the real key points on how the smoke alarm works. And the best way to do this was to get them up and acting as if they were parts of the smoke alarm, particularly to emphasise some of the misconceptions which come up a lot, i.e. this idea that they think the alpha particles move across the gap. And the whole idea the alpha particles had to go and touch an air particle and then the air particles start to move.
What happens then is the alpha particle basically ionises one of the air molecules. So as it goes past, it tracks the electron and it leaves the air molecule charged. So just sort of go past and just brush one on the way past.
To actually model it using them makes it very, very, very clear for them. And again, seeing the idea that the smoke comes in and what the smoke does actually stops the air from getting to them. The idea the smoke particles come in and they stand in the way so the air can't get there. It makes it very, very real for the students.
When we get up and do the demonstration, it helps you visualise the effects of how alpha radiation works in a smoke alarm. And if we do other demonstration, it helps you get your head round physically how it does it.
That'll stick in my head because I'll be able to remember, oh, someone grabbed hold of me because they were ionising me.
What happens with the smoke particles now is when they get in, they stop the air molecules, they absorb the ionised air, and the ionised air can't get over to the other side.
The thing about using the radiations officer is it can be used in a variety of ways. I've used it to start off the topic so you can get a whole lot of information, a whole lot of discussion about what they would expect from the topic in there. It can be used to get across any point at all going, because the key thing is the character carries it rather than necessarily having to be led by the actual content of the lesson.
I have here my guide counter which has been beeping away. And I have here a block of wood. And I have here a bit of americium.
Radiation is one of these topics where it's quite limited to the teacher doing demos rather than students being able to get hands-on that much. But it is actually really quite important that they get to see things like the guide counter working, and just the idea that they actually realise and actually get that real idea that there is a drop in the radiation when you put things in front.
If I put the wood in there, we end up with a drop in the count rate. Why?
Because the alpha particles are being stopped by the wood.
And why are they getting stopped by the wood?
Because they're huge particles.
Because they're huge. They can't get through. 2 protons and 2 neutrons means that they are quite big particles. Anyway, I suppose I now have to go and mend Mrs. McDougall's smoke alarm for her. She's very clumsy, your teacher. Thank you for your attention.
I take what she says seriously. I don't take the costume so seriously.
I think it's good that we all get into it and get along with it and play along and stuff like that.
I think it sinks in more, so you remember it easily. So it's better, it's better for my learning.